Good day, class. Today we are going to be discussing on the topic Introduction to Chemistry Laboratory, the apparatus and their what and their functions. So, as you can see, as a chemist, so for you to be a good chemist, you have to what? You have to familiarize yourselves with the laboratory. Why are you here? What are the things you do in the laboratory, and what, and so on. So today we are going to discuss basically on what, on the general introduction, the safety, and so much on laboratory. So let's start by what? By defining what laboratory is. We start by what? By defining a laboratory is. So a laboratory is a place where all the necessary what? All the necessary apparatus and equipments for what? For preparation of samples and standard of what? Various analysis for or of liquids, solid and what? And gaseous sample. As we all know, if you are in the laboratory, what are you here for? For an experiment. So the sample can be what? Can either be what? A liquid, solid, or gaseous what? Or gaseous what? Samples. And for you to carry out all this experiment, there are what? There are some apparatus or equipment to be used. So a laboratory is simply a place where all the what? The apparatus and the equipments are what? Are being gathered. It's just a building or a place where all these what? Apparatus and the what? And the what? And the samples plus the reagents, everything is gathered in the what? In the laboratory. So it's just a safe place where all you need to carry out the experiment is what? Is being kept. We start by what? The equipments that can be found in a chemistry laboratory. So there are so many equipments to be found in different laboratories. So depending on the laboratory. So basically our own discussion will lie on what? Chemistry laboratory. So as we mentioned earlier, the essential equipments in the laboratory are what? It includes the crucibles, the funnel, the watch glass, the beakers, the bottles, the flasks. You can see there are much here. So we are going to take one after the other. At least we give one or two functions of it. As we are saying, so among the main functions of all these equipments, we say there are plenty of what? Lab equipments used in the chemistry lab. Some are designed for single function. Some are what? Designed for single function. We are going to see the examples, like the graduated what? The graduated vessels or cylinders. They are used what? They are what? They are only used for measuring. They are only used for what? Measuring. You cannot say, I'm going to what? Use this for what? For mixing of chemicals or so. No. You only use this for what? For measurement. For what? As you can see, this is graduated 500 mils or 500 cm cube. It is made of what? Glass. And this one is the rubber type. This graduated what? 1000 cm cube or what? Or mils. That is what? One what? 1 dm cube. That is what? 1 dm cube. So this is half of this. So it is just, the difference is the material and the size. The material and the what? The size, the volume. This one is 1 dm cube, meaning 1000 cm cube. And this is what? Half of it. And the material made is, this is glass and this is what? Rubber. As I was saying, and we have orders that are designed for what? For several functions or uses. Like the what? Like the volumetric flux. Like the what? Like this is what? Our volumetric flux. This one is a very good example of it. Volumetric flux. This is measured, this is graduated what? 500 what? Mils. 500 mils. And we also have I was saying orders are designed for what? For several purposes, like the what? Like the volumetric flux. So this is our volumetric flux, and it is graduated what? 500 mils or 500 what? Cm cube, almost a half dm cube, right? 0.5 dm cube. If you are to what? It's just the unit that differs actually. So it is used to prepare solutions with accurate volume. It is used what? To prepare solutions with what? Accurate volume. Accurate what? Volume. As we have said earlier, in the case of measuring cylinder, you just use it for what? For measuring. You cannot prepare solution inside measuring cylinder. But this one, you can what? Prepare different solutions with what? With accuracy in the case of what? The volume. So this is called a what? A measuring what? Sorry, a volumetric flux. A what? Volumetric flux. So, and we also have some common laboratory what? Apparatus. Somewhat common laboratory apparatus like the beakers. We all know what beaker is. So this is a very good example. We have different size of the beakers. This is graduated 250 mils or cm cube. This is graduated 500 what? 500 what? Mils or cm cube. You see, it's just the capacity, the volume that differs. We have different size. This is 75. We have 100. We have 50. We have 20. Different what? Graduations. So, and they are all what? Made of what? Glass. They are all made of what? Glasses. Mostly, most at times, the what? The laboratory apparatus are what? Are made up of what? Glasses. We are going to see the reasons as we go. We have conical flux. We have what? Conical flux. So this is conical flux. It's called what? A conical flux. This is graduated what? 200 and what? 50 mils. We have a bigger one. We have a smaller one. So, but this one, it is what? Graduated what? 200 and what? 250 mils. So mostly it is used in as containers, like the beakers, the conical flux. It has many functions. You can use it as what? A container. And for the conical flux, you can use it in what? In titrimetric method. And we have and you can also use it as what? Reaction containers, like I've said earlier, either to hold liquid or solid. Both the what? Both the beaker and the conical flux. And we have glass funnels. We have the glass funnels for funneling liquid. But here, what we have is not made up of glass. It is what? A rubber funnel. So we can have that of the glass as well. This is what? A rubber funnel. What is the use of funnel in all this? It is used to what? Transfer liquids. So for you to what? Because some of the what? Like this one is the what? Test tube. You cannot use beaker straight like this to say you are going to transfer it into the what? Test tube. So you need something like this. So it will give you what? The exact amount. Because as a chemist and you want to what? Perform any experiment, even if it is a drop of the what? Of the sample or the reagent, you don't need to waste. It has what? Exactly, and what? Precise volume must be taken. So to avoid all any error in taking the readings, you have to what? You have to use funnels for transferring the what? The liquids. And also, you can use this same funnel for what? For filtering. For what? For filtering. How? When you what? By using filter paper. If you subject filter paper into it, you can use it to what? To filter out the what? You separate the what? The residue from the what? From the filtrate. Is that also? Yes. So this one is also another functions of the what? Of the funnel. And we have the measuring apparatus, as we have said earlier. You can use this. The measuring cylinder is a very good measuring apparatus. So these are the what? These are the common apparatus we have in the what? In the laboratory. So let's take some of the what? Importance of this laboratory apparatus. What are their importance? Why are they here? And most at times, these apparatus we are seeing, they are what? They are costly. They are what? So much amount of money is used to purchase all this. Then why are we buying this? Can't we just come to the lab, just measure it at random and do the experiment? It's not possible. It's not what? Possible. You have to get what? Graduated vessels, because it's from there you'll be able to know, okay, this is the exact amount I use and this is what I produce. Is that gotten? Yes. So let's see some importance of the what? Of the apparatus to what? to chemists. A science laboratory must be equipped to what? To allow students to actually perform experiment rather than just what? Read and what? And study in the classes. Because if you just continue reading and writing notes in the class without doing experiment, you see the what? You are going to miss a lot. Because you read, then when you come to the what? Laboratory, you experiment and you see. Because for example, if I say if you mix this and this, you are going to produce, if you mix A and B, you are going to produce C. I am just telling you and you write it. You have not seen it. But once you are in the lab, you'll be able to what? You'll be able to have a hands-on experience on what? What you have been taught in the class. So this is a very vital and important for the what? For a chemist. So note. So as you can see with the introduction I have given on all these apparatus, most of these are what? Are glasses. Why are they glasses? Why are they glasses? So as a scientist, you're supposed to ask yourself, why are they glasses? Simply they are glasses because glasses are easy to clean. Glasses are what? Easy to clean. Because after any usage, you what? You must clean it before another what? Experiment. And if you are using rubber, maybe some of the what? And this one is another important factor to consider, because if you are using, let's say, corrosive acid, if you use it on rubber, it is going to destroy the rubber. So this one is also another factor. That is why most of the apparatus are what? Are glass in nature, and it is also easy to clean. Please take note of this. I'm going to ask maybe at the end of the class, so you should take note of all this. Then you are in the laboratory, and we say laboratory is a place where we keep chemicals, where we keep all these apparatus. And we all know that some of these chemicals are dangerous to our life when we inhale or when it touches our skin and the rest. That is why we are what? Wearing all this lab coat and the rest, right? Yes. Then what are the laboratory hazards? What are the what? Laboratory hazards. So let's see the laboratory hazard and we see how do we be what? Be safe on all these hazards. Workers are exposed to numerous potential, which includes either chemically, biologically, physically, and in some cases radioactive chemicals also. Is that understood? Yes. For example, this is hydrochloric acid. This is what? Hydrochloric acid. If you try to open this, at most this should not be opened like this. We have what we call a fume cupboard. A what? Fume cupboard. Because if you open this, fume will come out. So, and it is toxic to our life. So there is what we call a fume carbon. A fume what? Carbon. So mostly in all these modern laboratories, we have what we call a fume carbon. So this fume cupboard is where you keep all this what? Toxic what? All these toxic chemicals in order to what? Because it has it tend to absorb all the what? Fume that will be coming out in the what? In the chemicals. So it will absorb them all to be what? It does that so that it should be what? Less toxic to what? To our health. So as the radioactive elements and so these are the potential hazards that as a what? As a student or any experiment worker that you may tend to be exposed to. So let's see how do we reduce all these hazards. So we move to what? Laboratory safety. So laboratory safety is essential part of what? Ensuring the health and safety of workers and researchers in the what? In the laboratory. In the what? In the laboratory. So that is why we are all wearing this what? Lab coat. Because in the case of any accident, first of all, the what? The chemical will not get in contact to the what? To the skin directly. So the effect will be reduced in the what? In the lab coat and so, and we pray such should not happen. So you have to be very careful. So we are going to see the general precautions and the precautions on handling all the apparatus. So generally, you should what? Once you are in the laboratory, you should keep away your hands, your what? You should keep away your hands from what? From your faces, your eyes, and nose, mouth, and the part of the body. Why? Why? Why will you do that? You should keep away your hands from your what? From your face, from your mouth, from your eyes, and the rest. Why? Because if you are in the lab, maybe you have touched one or two of the chemicals. And when you try to apply the hand in the face, you are now introducing the what? You don't know which type of chemical you have what? Touch. And you are now introducing hazard to your what? To the either part of the body. And food or what? Food or any drink, either open or closed, should not be introduced to the lab. Should not what? Should not be introduced to the lab. You cannot say, okay, I'm in the lab as a what? Researcher, I want to eat in the lab. It is dangerous because there are what? There are some gases that tend to move and maybe they will get contaminated to your what? To your food and causing what? Some health hazard. And last but not the least, never use glasswares for eating or drinking purpose. Like for instance, this one is our glassware for what? Hmm? Conical flask, right? For a layman, he can say, okay, let me use this for drinking. It's not possible. It's not what? Possible. Why? Because chemicals are being used inside the what? Inside the conical flask or containers. So you cannot use it for what? For either eating or drinking. For either what? Eating or drinking purposes. And once you are in the lab, whatsoever you are going to do, you should think safety first. Safety what? First. Safety what? First. So if you are in the lab, you don't say, let me mix this. No. Safety first. And before you are going to take experiment with each chemical, you need to what? Before the experiment, you need to go and what? Find out that you see in the, let me show you one. In the what? Like for instance, this one, hydrochloric acid. Look at some what? Some label have been done there. So this label of what? Skeleton system is saying that it is what? It's corrosive. It is what? Corrosive. So as a good researcher or a good chemist, if to say, okay, we are going to have experiment on this chemical, so what do you need to do? You should go and what? Make research on the chemical to be used. Which type of chemical am I using? Is it flammable? Is it hazardous? At least you should go and find some what? A little knowledge on the what? On the chemical before you use. And most of the what? You see some different labelings. Like this one is ethanol. You will see it is just what? Written harmful and what? Flammable. It doesn't have that skeleton whatsoever. Because that is saying that this is more hazardous than this. But even this one is harmful. But this is more hazardous than what? Than the ethanol. Than the what? Than the ethanol. Is that understood? So this is the general precautions to be taken. And let us see one or two of the precautions to be taken when using the what? The apparatus. Never touch, taste, or smell any reagent. Never what? Touch, smell, or what? Or taste any reagent. Let's say we are in the lab now. All these are what? Are chemicals, even though they are labeled, but you are not the one that prepare it. So you don't say, okay, is this? It is written dilute hydrochloric acid. You say, let me open and test it also. You should not even touch. If you are not the person that prepare it and keep it, don't even touch. Because maybe someone has what? Maybe it's not dilute hydrochloric acid. He just try to what? Add it inside due to due to what? Poor practice. So if you are not the person that prepare any reagent also, you should not touch. Even if you are the one that prepare, you should not smell or taste. Even if you are the one that prepare. But if you are not the one that even prepare it, don't even come close to it. Don't touch it. So this is a very good precaution to be taken. And when you are using the glasswares, laboratory glasswares should be washed, rinsed before and after what? Use. Should be what? Washed, rinsed before and after use. To what? To avoid what? To avoid what? Why will you wash and rinse? It's to avoid contaminants. To avoid what? Contaminants. And we also have chemical wastage should be minimized. For instance, you want to just do some titration, then you prepared so much amount of the chemical, because I have told you earlier, these chemicals are what? They are very costly. So you should minimize the usage of what? Of what? Of the chemical. So to avoid chemical wastage. So as a good chemist or good practicing chemist, you should what? Make sure that you should avoid what? Wastage of what? Chemicals. Do not throw hot concentrated acid into the sink. For example, this is our what? Hydrochloric acid. Let's say you measure out, let's say maybe you want to use only 50 what mils, and you try to also you got like 150 mils. So before getting what you needed, then you say you spill it out into the sink. You should not what? You should not do that. Why? Because it is concentrated. It is what? Concentrated. Due to the concentration, it can what? Destroy the layer of the what? Of the sink. Yes. If to say it is concentrated, it will what? Destroy the layer of the sink. So this one is also another precautions when handling reagent. And when you are to what? Take out the experiment, you should follow step by step. Step by what? Step. Don't say, I have read the procedure. You go and carry procedure 4 before procedure 1. You are on your own. Because these steps and procedures are what? Are the steps to be followed, because maybe this reaction will what? Will be initiated first. But for you, you went and take from from procedure 1, you move to 4, you skip 3 and 4. Automatically, at the end, you are not going to get accurate result. And maybe some dangers may tend to what? Occur. Yes, you don't know. So you have to follow what? Due process, or you have to follow step-by-step procedure in carrying out the what? The experiment. And the last but not the least is that you should report any accident if occurred. You should what? Report any accident if occurred. Under this, you are not supposed to work only you in the laboratory. Yes, under laboratory ethics, only you should work in the laboratory. Is not advisable. Why? Because in the case of any accident, maybe one will help. So even if he is not going to be part of the what analysis, should find somewhere and hang around. At least you should be supervised, or you should have someone to what? To stay nearby in case of any accident or so. And the last, under this, you should be well organized. You should be what? Well organized. Once you are in the laboratory, there is nothing like, let me finish and go. No, because you are dealing with so many harmful substances, hazardous substances, the place, all these glasses are what? Are fragile and the rest. And the cost is so much. It may even cost, you don't know which type of chemical is this, maybe when reacted to this. So you have to be what? Very careful in what? In making all these steps. So you should be what? You should be what? Well organized once you are in the laboratory. So I think with this introduction, so let me add more to this. I'm expecting maybe some of you will ask, why are these stored? We have two types of bottles actually. We have the amber bottle and the transparent bottle. Look at this. All these liquid reagents, they are what? They are stored in amber bottle. Why? Because we have what we call a photolytic reaction. We have what we call what? A photolytic reaction. A photolytic reaction is a reaction that tends to occur when there is what? Presence of light. So, and we have photolytic compounds. Automatically, they are what? They are compounds that when there is presence of light, they tend to what? They tend to react. That is the main reason. Most of these chemicals are what? Are stored in amber bottles. And furthermore, look at this now. It's called what? Isopropyl alcohol. Iso what? Propyl alcohol. So this is what? A reagent that is what? That is inorganic in nature. That is what? Inorganic in nature. If you could have recalled, we have said earlier, most of the inorganic what? Reagents are what? They are not corrosive. Most of them, they are not what? Corrosive. Look at, that is why it is stored in what? This is a rubber container. You cannot store hydrochloric acid here. Why? Because of the corrosive nature of it. So this one is also another factor to be considered. Is that understood? So, but you see the labeling, it is flammable. So once you see flammable, you cannot use what? Open flame. That is why we have what we call the what? The water bath. The what? The water bath. So this water bath, you what? You introduce water to what? This is the inlet where water will be introduced to it. And this is the what? Inlet. Let me raise it up. This is the inlet for what? It is an electrical device. So this is the inlet of the what? Of the energy source, electric what? Source. So if it is connected, then water will be added to it. So this is used in the case of what? When you want to heat the reaction, and that what? Maybe the chemical you are using or the reactants are what? Are flammable. You don't use open flame. You don't use what? Open flame. You don't use what? Open flame. Then this is our what? Tripod stand. This is what is this called? A wire goes. We have our bonsimbona. So this is used in the case of what? In the case of heating, if the what? If the reactants are not flammable. Are not what? Flammable. Is that understood? So whensoever you want to do analysis, you should what? All these factors need to be considered. So and we also have what? Some solid reagents here with us. This is sodium carbonate. So even some of the solid reagents, they are what? They are stored in amber bottle. Why? Because they are what? They are photo what? They are photolytic in what? In nature. But look at this. Some are just stored in normal bottles, but in most cases they are not transparent in nature. In most cases, because different salts and different solid samples have different behaviors to what? To temperature and the rest. So the last but not the least, what I want to say on this is even the glasswares. We have two types of glasswares. There are those that can be used for heating, and there are those that you cannot use for heating. It is also very important. So if you went and use those that are not what? Used for heating, in the case of heating reagent or any reactant, there will be what? Breakage. So those that are used for reagent for what? For heating, in most cases, you will see it is what? It is labeled there, like this one. There are those that are used that can be used for heating. We have the borosilicate glass and we have a pyrex glass. What? Borosilicate glass and what? Pyrex glass. And one beauty of this, all the glasswares will be labeled. If it is what? It can be used for heating, like this one now. This is our round bottom flask, volumetric flask. You see? Borosil glass. Boro what? Seal glass. Meaning you can what? You can hit this. It is made up of what? Borosilicate. And in some cases you see pyrex. You see what? Pyrex. So it's just different manufacturing companies. But in most cases, beakers can be used to heat in low temperature. Beakers. Generally, beakers can be used for heating under low temperature. But apart from beakers, if you are to heat any of the glassware that can be used for heating, it must be what? Pyrex or what? Borosilicate glass. So I hope by now at least you have been introduced to so many different and we have what we call the pipettes. So this one are simple setup for what? For titration. This is our what? Retort stand. You all know this. Then this is our burettes that will be used to clamp here in the case of what? Acid base reactions, right? Okay, this is our pipette. Sorry, our pipette. It is what? Graduated 25. We have that of the 12.5. We have 25. We have 50. And this one we have, this is 50, graduated 50 mils. We have 100. We have 25. Different, it depends on the what? On the volume. This is our what? Our brush for what? For washing what? Our what? The test tube and so many of the what? You don't use your hand to say, let me rinse it with my hand. No. You use brush. You use what? The brush. This is called the tongue. It's called the what? The tongue. What is the function of this? Yes, you hold what? Glasswares that are being heated. Yes, glasswares that are what? Being heated. When you want to heat any glassware, so you use tongue to what? To pick it up. Because you cannot use your hand to pick it up. You use what? Tongue. This is called the test tube what? Rack. It's called the what? Test tube rack for holding many test tube. This is our test tube for what? For reacting either solid or liquid samples. We have what we call so even the test tube, you have two different types of, we have so many different types of what? Test tube. Like this one, Pyrex written, Pyrex. Meaning you can what? You can hit this one. If it is not being labeled, you are not going to hit it. If you hit it, it's going to what? Break. Like this one, it is not being written Pyrex or borosilicate glass. So you cannot hit this. You cannot what? Hit this. So we have different sizes of the test tube, but mostly the test tubes are not graduated. They are not what? No any measurement that is written. When we say a container is graduated, meaning what? It has a specified measurement written in the what? In the, this is called the watch glass. It's called the what? Watch glass. As you can see, you can see through it. That is why it is called what? Watch glass. It is being used to what? To measure out what? Solid samples. To measure out what? Solid samples. You can see it through from the word watch. So it's called what? A watch glass. We have different sizes of it as well. This is our watch bottle. You use it for rinsing the what? The apparatus. So that is all what we can say for now. This is our litmus paper. This is what? Litmus paper. We have the blue and the red, used for testing acid and bases. Which one is used for testing acid? Red. It will change to what? It will change to blue, and the blue is used for testing what? Bases or alkalis. It will change from what? To from blue to red. This is our what? Our indicator bottle. It's just a container. Our indicator bottle. This is the dropper. Is the dropper. We have a rubber one. It's just a container like this, and this is the dropper. This is the what? Dropper. So I think with this introduction, you'll be able to what? All these ones are also what? Containers or bottles. So this is amber, and this is what? Transparent. We use this to store what? Photolytic what? Photolytic what? Photolytic compounds or reagents or reactants. And this one we use to what? Non-photolytic what? Compounds can be stored here, because this will not allow the passage of light. Will not allow the what? Passage of light. So upon what we have said earlier, so I think with this we can call it a day. Sorry, I have not introduced this. This is what? Is what? A beam balance. What do you use beam balance to do? For what? For measuring solid what? Samples. For what? Measuring solid samples. Under quantitative analysis, we said we have the what? The volumetric and the gravimetric. So the gravimetric is what? Is the direct measurement of what? Mass. So we use different types of what? Among them, this is also an instrument that can be used to what? To measure out direct mass. We have the modern type, so many differences. So this is one among what we can be used to what? Measure out solid or liquid reagent, to measure the mass. Is that understood? Yes. So I think before we call it a day, any questions from you? There is question you ask. Yes.
You have said before.
Yes.
Why did you store this chemical in this amber bottle?
Yes, as I have said earlier, chemicals are stored in amber bottle to what? To deprive light from coming in. Why? Because we have what we call a photo what? A photolytic compounds. A photolytic what? Compounds. So these photolytic compounds from the word photo means light. So they like what? Light. As soon as they absorb some amount of light, it will what? They will start to react because they have absorbed what? Energy. So for a reaction to occur, they need what? Energy. And energy in form of light energy will be absorbed if they are not stored in amber bottle, and they will tend to initiate reactions. That is why they are being stored in amber bottle. Any question?
What are corrosive reactive reagents?
When we say a reagent or any chemical is corrosive, meaning it can what? It can cause harm to the what? To the skin. It can burn the skin. It can what? Burn the skin. So such type of chemicals or reagent are called what? Corrosive. So let me ask questions also. Why is it that some chemicals are stored in bottle and some are stored, sorry, in glasswares, and some are stored in normal non-glasswares? Why? Anybody with an idea? Why? You want to say something? Okay. Why is it that some chemicals are stored in glasswares and some can be stored in bottle or non-glasswares? Why? Rubber, like rubber bottles or non-glasswares? Why?
Most of chemicals that are corrosive are stored in rubber, are
Oh,
stored in non-rubber bottles.
okay, like the glass, like the glass. Why? It's due to the corrosive nature. It's due to the what? Corrosive nature. So I think with this we can call it a day, and inshallah when we meet next, we are going to elaborate more on what we have said. So assalamu alaikum warahmatullah.